In this video, we try to learn how to convert general form of a quadratic function to standard form without using completed square each time. But before we can actually do that, we have to learn how to derive the formula in order to convert general form to standard form. Let's take a look here. And it says, okay, the maximum of minimum value of a quadratic function f(x) equals ax squared plus bx plus c occurs at x equals negative b over 2a. Remember, this actually is the h, okay? And so then we can find a k from if h is given, and then we can from h get k there. But the question here is how come the h actually equals negative b over 2a? So let's start from the function here. Fx equal to ax squared plus bx plus c there. And so this can be written as the following. As always, we factor the a outside of these two terms because we want to make the leading coefficient 1. So we factor the a, I get x squared plus the b. If you factor out a, so you can actually have b over a x. So if you multiply back to here, you can see a reduced, then you're going to get back to the b x there, okay? And the plus c there. As always, and we want to complete the square, so that means we're going to do the following. We're going to add half of that thing squared. Half of this means b over a half, so that equals b over a times 1/2. So that's give us b over 2a. So that give us b over ax plus, okay, b over 2a squared. And so you add a term, you have to subtract the same term, so the function value will not change. If you cancel this, you're still back to the same function as before. Okay, but since we want to complete the square, so means I want to write this free term as perfect square. So that's the way we have to do. Okay, so now you can see I have a. This free term is perfect square x plus whatever that thing here is b over 2a squared. And it's a times that thing here. Okay, minus a times b squared and 4a squared, and add c there. So now let's simplify this here. That thing here, you can see I'm going to write this a reduced. So here you have b squared divided by 4a and plus c. So that's just that part. So continue. If we we just combine these two together, you need to get a common denominator, which is 4a, So we're gonna write negative b squared 4a plus 4a, and here you multiply 4a to the numerator to the denominator, you get 4ac. Okay, so here now that thing I'm gonna rewrite that thing here. Okay, finally I'm gonna rewrite this as ax plus b over 2a squared. I write this first. Okay, so I'm gonna write plus 4ac, and the second term I will minus b squared divided by 4a. Okay, So now you can see here, this is equal to x minus negative b over 2a plus 4ac minus b squared divided by 4a. So now you can see the h equals negative b over 2a, and the k is simply equal to 4ac minus b squared divided by 4a. Okay, so now if you remember in this part, it's easy to remember, but this one you don't have to remember, because what you have here, you can see when you choose x equal to negative b over 2a, so that will be 0. Okay, now all you need just evaluate f of h. You don't have to remember this part. Okay, remember this part. So that's here, and we get h equals negative b over 2a there. Okay. So now here, same thing here. Okay, now you know why. So here, okay, when x equals negative b over 2a, which is h, if a greater than 0, f of h, which is negative b over 2a, f of this, so this actually equal to k. This also equal to k there. Okay, depend on a greater than 0, less than 0. If a greater than 0, this opens, because the graph opens upward, so it has minimum. Okay, if a less than 0, the graphs open downward, it has, okay, maximum there. Okay, so that's how. So now you don't have to remember, okay, how to do the complete square if you remember how to use this formula there. Okay, let's take a look at a specific example there. Okay, see, let's take a look at this example. I do not want a complete square. So I don't want a complete square. So what I do here, I identify a equals 2, I got a b equals 4. So that tells us h equal to negative b over 2a. b over 2 times a, which give us 4 divided by 4. But since you have a negative sign, you get a negative 1 there. Okay, so, and what is the k? K is f of h, which is negative 1. So you just simply evaluate f of negative 1, 2 times negative 1 squared plus 4 times negative 1 minus 1. So you have a 2, negative 1 squared is positive 1, times 2 is 2, plus 4 times negative 1, so negative 4 and minus 1. So you combine that together, 2 minus 5, which is negative 3. So you can see here you have h is negative 1, k is negative 3. So now you can write the standard form, okay, fx as a, which is 2, x minus h plus k, which is negative 3. So you write the standard form. And also, because here's a equal to 2, a equals to 2 greater than 0, so f has a minimum. What is the minimum value? Which is negative 3. F of negative 1 equal to negative 3. That's the minimum. Okay, so you can see I do not need use complete square, so all I need forgot h. From h, I can find what is k. So then I can write standard form that I can easily identify the minimum or maximum. Okay, that's the first one. Let's look at second one. So here, again, I let a equal to negative 1/3, okay, and b equals 2. So here, the h equals negative 2 times a, which is negative 1/3, times, Okay, the b is 2. So now you can see here I have a negative 2 divided by negative 2/3. Okay, so go ahead to simplify this as negative 2 multiply the reciprocal of that, which is negative 3/2. Double negative becomes a positive, reduce 2, so you actually get a 3 here. So h equal to 3. So the k equal to f of 3, which equal to negative 3 squared divided by 3 plus 2 times 3 plus 7. So that gives us 9 divided by 3 squared is 9. 9 divided by 3, which is 3. So negative 3 plus 6 plus 7. Okay, so here now you can see negative 3 plus 13. So that's give you positive 10. So the vertex is 3, 10. So that tells us the standard form for this function is fx equal to and negative 1/3. Always write the a first and x minus h, which is 3, plus k, which is 10. So now you can see because it's a less than 0, so a equals negative 1/3 less than 0, f has a maximum because open downward, it has a maximum. Okay, so that maximum is f of 3 equal to 10. Okay, so that's what you can see. We don't have to use the completing the square process, and we can write a standard form and also can identify the vertex and the minimum or maximum there. Okay, so next what we try to do here is very quick application. Okay, application. So here we have this problem. A farmer has 2,000 feet of fencing to fence in a rectangular horse corrals, and we want to find a function that models the area of the corral in terms of the width of x. And so b, we find the dimension of the rectangle that maximize the area of the corral. Okay, so look here. Okay, so here we can consider this as a rectangle because you have 2,400 feet of fencing. But look, the 2,400 feet of fencing, you can make many different rectangles. Okay, you could make this way, you could make like this way, okay, you could make this way, okay, so here many ways, but we want maximize the area. You use the same length of the fence, but you want to get a maximum area. Okay, so let's see here, because this is the x, so that means you have a 2x because you have a 2 width. Now, what is the length? This is the length. This is the length. You can see that. So you can see here we have 2 width plus 2 length. That's give you the total length of the fencing. Okay, so which is 2,400. And so here I want represent the length in terms of x. So which means I need to solve for the L. So here I have 2L equals 2,400 minus 2x. Both sides divide by 2. That's divided by 2 is 1,200. That's divided by 2, which is x. So the length actually equals 1,200 minus x. So now you can see here the area, we use A, represent AX equal to length times width. The length is 1200 minus X times width, which is X. So now you can see this is a quadratic function. So here I go ahead to distribute this. I have 1200 x minus x squared. Or I rewrite this as the form as rewrite in a different order, minus x squared plus 1200x. So now we want to find the area, maximum area. Because in this case, you can see you got a equals -1, which is less than 0. Okay, so that means a has a maximum. Okay, in order to find maximum, so here that means I'm going to use h equals negative a, which is b, which is this one, b equals 1200 divided by 2 times a is -1. So you can see here, and that's basically you have negative 1200 divided by -2, so double negative become positive, which is 600. So the k, which is a of h, which is 600. So you can see you have a 1200 minus 600 times 600. So that gives us 600 times 600. 360,000 square feet. So now basically we are done. So here we're going to say, okay, when the width equal to 600, okay, and so here, and the length, because length equals 1200 minus the width, 1200 minus 600, which is the same thing here, 600. Okay, when the width equals 600 feet and the length equals 600 feet, and the rectangle has a maximum area. Okay, so that's what we have here for a very quick application. That's the end of this video.